Dijkstra. How does Google Maps actually calculate the shortest path from place A to B? Well, it mainly utilizes the logic of two algorithms, best first search and Dijkstra's. But today, we're going to be unpacking Dijkstra's. Dijkstra's algorithm is a graph algorithm used to find the shortest path between a starting node and all the other nodes in a graph. Each edge of the graph has a weight, and Dijkstra's algorithm uses these weights to determine all the different shortest paths. Okay, so how does it actually work? Well, it starts by assigning a starting node. It picks a starting node and it assigns that node a distance of 0, which makes sense as you don't have to move to go to where you already are. Whilst we assign the distances of all the other nodes in the graph to a distance of infinity, as we haven't been able to actually find out the distances yet. Then we update the distances of adjacent nodes by adding the weight of the edge between the two nodes to the distance of the shortest node. Okay, this is getting a bit more complicated. I reckon we just go straight into an example and go from there. Cool, so in our example we have a graph with 6 nodes and 8 weighted edges. Step 1, we need to actually pick our start node. I say we pick node E. As we discussed before, we first actually need to initialize the distances of all the nodes from E to themselves. So we set the distance of node E to 0 and the rest to infinity. We haven't figured that out yet. Cool, so step 1, tick. Now we need to first inspect all the adjacent nodes of our start node E. So we need to use the edge weights to update the distances between E and A and E and C. So now A has a distance of 7, which we determine with the edge weight between E and A, and C is updated to a distance of 8. Similar story, updated via the edge weight, E to C being 8. Now that we have looked at all the neighbours of E, we've now visited E, and we can now start visiting the node with the shortest distance from our start node E that still hasn't been visited. So basically, we're going to look at the next shortest node with the shortest distance from E. So this node happens to be A. It's got a distance of 7, whilst the other one has a distance of 8. And now we're going to actually inspect all of A's neighbours and see if we can update their distances. Well, node A has a distance of 7 and the weight of the edge connecting A and F has a distance of 8. So now we can reach F with a distance of 15, which is undeniably a lot less than a distance of infinity. So we're going to update F. But we don't update the distance of node C, as the distance going via node A from E to C is larger than C's current distance of A. Cool, so now we've visited A. Then we continue on and we kind of repeat the process. We go to the next node that is unvisited and has the shortest distance. So this node is now C. Here we can update the distances of two nodes, D and B, as the distance from node E to D and B to C, and B via C is a lot shorter than infinity. We update the distances and C has now been visited. Now we pick node D and repeat the previous process yet again. We can't update our distances of nodes C and B, so we've just visited node D, and you'll find a lot of the time that we aren't necessarily going to be updating nodes distances. That's not always going to happen. Cool, so now we're left with two nodes, F and B. As F has a shorter distance from node E than B, we pick F. Whilst we cannot update the distance of node A, as the distance from node A to F is 15 and the weight of the edge between F and B is 2, we can update the distance from 18 to 17. We have finished with F and are now left with B. We can't update any of B's neighbour nodes, so B has now been visited and boom, we've just run Dijkstra's algorithm. Having now seen how Dijkstra's runs on a graph, we can imagine how it could help Google Maps choose the shortest path between two locations. We have the edge weights as actual distances, whether that be in miles or kilometres, and the nodes as our locations. So that's Dijkstra's algorithm in a nutshell. It's a graph algorithm used to find the shortest path between a starting node and other nodes in a graph. To get more content on cool graph algorithms, please like and subscribe. Thank you!